We are the team of AP078. We have done project Autonomous Car. We are the team members. We had done the project under the guidance of Mr. Sham sir and Mr. Irfan Ali sir. We have considered a problem statement. Let's have a look. Every year, millions of people are dying due to car accidents. So this is an issue of serious concern. Deaths or serious injuries in car accidents affects the families of the individuals completely for their lifetime. As per the observations, the primary causes of these accidents are cell phone usage while driving, overspeed, violation of traffic rules, and bad weather conditions. To overcome these serious issues, we came up with a solution to design an autonomous car by using DE10 Nano Fpga board. Here are the features what we implemented on our design. Collision avoidance system, GPS based routing of vehicle, lane detection, object or obstacle detection. Let's see how design works. Here, camera, sensing unit and GPS unit sends the data to the Fpga. Here the Fpga processes the data and sends to displaying unit and microcontroller unit and communication unit. Let's see the architecture. Here, camera, lidar and the ultrasonic sensor sends the data to the Fpga. The data received from the camera is used for object detection and the lane detection. The data received from lidar and ultrasonic sensor is used for obstacle avoidance. GPS module and cloud sends the data to Fpga for destination arrival purpose. Fpga, which is a processing block, processes all the inputs and sends the output to the Arduino and motor driver for steering and thrusting control of car. And also Fpga sends the output to the display. This is our hardware design prototype. Our hardware design prototype consists of information block, processing block and controlling block. Okay. First of all, let's have a look about components. This is lidar. This is ultrasonic sensor. This is camera. This is DE10 Nano Fpga board. These are the motor drivers, Arduino board and RFS module. Let's see how our hardware prototype design works. Firstly, the lidar and the ultrasonic sensor and the camera sends the input data to the Fpga board, which is a processing block and a controlling block. This Fpga board processes the data which was sent by the information block and send the control inputs to the Arduino and to the motor driver. The data which was sent to the Arduino is used for the servo control for steering action, and the data which was sent to the motor drivers are used for thrusting of the car. Now let's see how we performed object detection. We have taken live video as input and converted into image frames with a particular time intervals. We converted the image into grayscale and used image enhancement technique to get sharpen and bright image. We applied smooth filtering to remove noise. Then we used hard cascade classifiers to detect moving objects. Finally, the output frame is given with a rectangle over a detected objects. For the lane detection, first we take an input video from the USB tethered mobile camera. Then we resize the input image for optimized processing and for convenient display. Then we convert the image from BGR to HSV. We use HSV color space because it describes colors in terms of hue, saturation, and value, which makes a better representative model of color. After that, we make a mask with the above extracted output. Now, we perform bitwise operations to delete unnecessary colors and to extract the yellow color on the road dividers. Then the extracted output is converted into grayscale. And on the grayscale image, we apply Gaussian blur. Gaussian blur is nothing but Gaussian smoothing. It results of blurring an image and removing noise. This helps in doing edge detection better. Can edge detection is performed on that extracted output to detect edges. After that, we select our region of interest to avoid unnecessary edges. Half transform is performed on the image. Finally, from the points of detected lines in half transform, we draw the lane lines. Now see the output frame. GPS based routing vehicle. We are using Azure Maps. In Azure Maps, we are sending a GET request to get the coordinates. So here is my starting location and this is my destination location coordinate. Now I am sending a GET request to the Azure Maps. Here I got the coordinates from starting location to the destination location along with the directions, and these coordinates will send to the FPGA board. Here the FPGA process the coordinates by checking my current location coordinate with the nearest location coordinate in the path. If you reach to that path, then automatically the location will be get updated, and this process continues until you reach the destination point. Movement of the car when there are obstacles on either sides of the car. Movement of the car in a curved path. Obstacle avoidance when there is an obstacle present at the right side of the car. Obstacle avoidance when there is an obstacle present at the left side of the car.